Good morning. Study material, session 36. Correlation coefficient problems. Calculate the coefficient of correlation and probable error between the two series A 10, 28, 49, 50, 70, 75, 98, 100, 110, 120. B series 112, 110, 75, 60, 55, 50, 40, 30, 20, 10. There are two series, A series and B series are there. We have to calculate the coefficient of correlation between the A and B. Any relationship is there between the A and B. If the relationship is there, what type of the relationship between the two, whether it is the high degree, medium or low, and then we have to calculate the probable error between the two series. Here A is assumed as the X series 10, 28, 49, 50, 70, and Y series 112, 110, 75, 60, 55. After taking down the X series and the Y series, we have to calculate the deviation. Here the deviation has to be taken from the arithmetic mean of the first series. X bar is equal to sigma X. The total of the X series is 710 divided by N. Number of items here is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total is 10. 710 divided by 10, it is equal to 71. 71 is the arithmetic mean of the first series, as we assumed is the A series as the X series, and the X bar, it is equal to X bar is the arithmetic mean of the first series is 710 divided by 10, it is equal to, it is the 71. We have to take the deviation from the 71 for the first series. First series values are 10, 10 minus 71, it is equal to minus 61. 28 minus 71 minus 43. 49 minus 71 minus 22. 50 minus 71 minus 21. 70 minus 71 minus 1. 75 minus 71 4. 98 minus 71 27. 100 minus 71 29. 110 minus 71 39. 120 minus 71 49. So these are the X values, that it is the deviation which has been taken from the arithmetic mean. Here the arithmetic mean is 71. Then Y series deviations has to be calculated. It is denoted by Y. Y minus Y bar. Y bar, the total of the Y series is 562. 562, here counting the number, it is equal to 10, 56.20. 112 minus 56.20, 55.8. 110 minus 56.20, 53.8. 75 minus 56.2, 18.8. 60 minus 56.2, 3.8. 55 minus 56.2, minus 1.2. 50 minus 56.2, minus 6.2. 40 minus 56.2, minus 16.2. 30 minus 56.2, minus 26.2. 20 minus 56.2, minus 36.2. 10 minus 56.2, minus 46.2. So the deviation which has been taken from the arithmetic mean of the X series, and the Y values are the deviations which has been taken from the Y bar, and these deviations has to be squared. Minus 61 into minus 61, 3721. Minus 43 into minus 43, 1849. Minus 22 into minus 22, 484. Minus 21 into minus 21, 441. 1 into 1 minus 1, it is equal to 1. 4 into 4, 16. 27 into 27, 729. 29 into 29, 841. 39 into 39, 1521. 49 into 49, 2401. Y square, the deviation which has been taken from the y bar, 55.8 into 55.8, 3113.64. 53.8 into 53.8, 2894.44. 18.8 into 18.8, 353.44. 3.8 into 3.8, 14.44. Minus 1.2 into 1.2, 1.44. Minus 6.2 into minus 6.2, 38.44. Minus 16.2 into minus 16.2 to 62.44. Minus 26.2 minus 26.2 for 686.44. Minus 36.2 into minus 36.2, 1310.44. Minus 46.2 into minus 46.2, 2134.44. Then you have to get the minus 61 into 55.8 minus 3403.8 minus 43 into 53.8 minus 2313.4 minus 22 into 18.8 minus 413.6 minus 21 into 3.8 minus 79.8 minus 1 into minus 1.2 1.2 4 into minus 6.2 minus 24.8 27 into minus 16.2 minus 437.4 29 into minus 26.2 minus 758 9.8 39 into minus 36.2 minus 1411.8 49 into minus 46.2 minus 2263.8. All the positive values has to be added and the negative values has to be added, and you have to get the sum of the xy. X is the deviations of the first series. Y is the deviations of the second series has been multiplied. Then these are the multiplications of the xy. Now we have to get the summation. It is equal to 11,107. For the correlation coefficient, we have to apply the formula sigma xy divided by square root of sigma x square into sigma y square. It is equal to minus 11,107. Sigma xy is minus 11,107. Then root of sigma x square 12,004. Sigma y square 10,809.6. It is equal to minus 11,107 divided by square root of, remove the square root of 12,004 and square root of 10,809.6. It comes to 11,107 divided by 109.56. Root of 12,004, it is equal to 109.56. Root of 10,809.6, it is equal to 103.96. If you multiply the 109.56 and 103.96, we will get, it is the 11,390.86. If we divide this one, we will get R is equal to minus 0.97. It is a perfect negative correlation. High degree correlation, negative correlation, or here we are finding the relationship between the A series and the B series. It is equal to 0.97. Then we have to calculate the probable error in this problem. The formula for the probable error is 0.6745 into 1 minus r square divided by root n. 0.6745 is the standard error. 1 minus r, we got it as the minus 0.97 minus 0.97 square. Then root, how many are there? 10 series are there. In the series, 10 pairs are there. It is the n is equal to number of items here is the root 10. It is equal to 0.6745 into 1 minus 0.94. 0.97 into 0.97, it comes to 0.94 divided by 3.17. Root 10, it is equal to 3.17. 0.6745. When you divide 1 minus 0.94 divided by 3.16, it comes to 0.01898. Here the multiplication of these two, it is equal to 0.01. Here 0.01 is the probable error. Here we are asking to calculate the coefficient of correlation as it is the minus 0.97, and probable error between these A series and B series is 0.01. With the help of this one, the management can take the here decisions with regard to the A and B. The management wants to establish the relationship between the A and B, and the relationship is perfectly negative correlation. So this is the here outcome of the correlation coefficient, and the probable error, it is equal to 0.01. These two are helpful for the management. In the same way, in the second problem, we have to calculate the Karl Pearson's coefficient of correlation from the heights of father and son. Father's age is given, father's height is given, son's height has been given. We have to calculate the correlation coefficient between the father's heights and son heights. Here, we have to write it as the heading as the calculation of Karl Pearson's coefficient of correlation. And father's heights be considered as the X series, and son's height will be considered as the Y series. Here we have to calculate the X bar. X bar is equal to 67. 469 is the total, and how many terms are there means 1, 2, 3, 4, 5, 6, 7. 7 terms are there. It is equal to 67. 67 is the X bar, and Y bar, total of the Y series is 476, and n is equal to number of items is 7. 1, 2, 3, 4, 5, 6, 7. 7 items are there, and Y bar, it is equal to 68. Correlation coefficient between these A series, that it is the father sides and the son side, it comes to 0.81. Hence, there is exists a strong positive correlation between the two series, father's heights and son's heights. So this is the question which has been asked. In the same way, we have to calculate the coefficient of correlation from the following data. X series has been given, Y series has been given. We have to take the deviations from the arithmetic mean. Arithmetic mean of the X series is 10, Y series is 8, and correlation coefficient is 0.89. Hence, there existed strong positive correlation. From the third also, we come across that the relationship between the two are strong positive correlation. In the fourth one, find out the Karl Pearson's coefficient of correlation from the following data of income and weight. Income, weight. The correlation coefficient here, it is equal to 1. There exists a positive correlation. So this is the here a positive correlation, perfect correlation. Next is we have to calculate the coefficient of correlation between the price and demand, as well as find the probable error here. Here the correlation, it is the 0.98 minus 0.98. Then we have to simplify so that we will get the probable errors as the 0.008. 0.008. So these are the problems which is helpful for us to know about the how to find or establish the relationship between the two series, and whether it is the in the same direction is there or in the opposite direction is there, we have to find it. And so that we can draw the conclusions between the two series is having a perfect relationship, that it is the positive correlation or negative correlation, what is the probable error. And these are helpful for the management to draw the conclusions with regard to the relationship between the two series. Thank you.